welcome back, Math 30-1. Today we are going to look at how to use synthetic division to divide a polynomial by a binomial. First thing I want you to look at is, this is the same thing as x is equal to, what? 2, okay? And then think of it that way, right? So that's kind of why I had to put the 2 there. Now I'm going to just show you and explain everything to yourself. I look at this, x is equal to 1, okay? So we have a 1 there. Here's my equation. Each coefficient from each term going down. Notice how it's degree of 3, so that means we should have 4 terms. Okay? Now, what I'm going to do is, we bring down the 2, and we first go 1 multiplied by 2, which will give me a total of 2. Then we go, we add these together, we're going to get negative 1. This multiplied by that gives me negative 1. Add those together, we get negative 9. This multiplied by that gives me negative 9 multiplied by 1. And I add these together, I'm going to get 6. Now I want it in this form. So I'm going to first go, I know product is equal to my divisor multiplied by my quotient and plus my remainder. So I put it always in that way first because it makes more sense to me. So my divisor is x minus 1. And my quotient is, right here, if I look at this, this is x squared. This is going to be x, and that's that, and this is my remainder. So we're going to have 2x squared minus x minus 9, and we have plus 6. Okay? Now, I could put this into this term very easily. So we have, right here, we have 2x to the power of 3 minus 3x squared minus 8x plus 15 all over x minus 1 is equal to 2x squared minus x minus 9 plus 6 all over x subtract 1. Now isn't that very fast and easy? Class example number 2. It says use synthetic division to find the remainder when we have this equation divided by that equation. Now for this one, we have to remember that x is equal to negative 2. So I'm going to put negative 2 there. Okay? And we have 5, negative 6. Now, there should be an x cubed, but it's not showing, so I'm going to put 0, because there's 0 x cubes. Then we have 3x squared, we have negative 2 x's, and we have 1 constant. Okay? Now, let's take a look at this. We bring down the 5, we have negative 2 times 5 is negative 10. Add these together, we get negative 16. Negative 2 times negative 16 is 32. Add these together, we're going to get 32. Negative 2 times 32 is negative 64. Add these together, we're going to get negative 61. Negative 2 times negative 61 is going to be negative or positive 122. Yep, 122. And this is going to give me 120. And we add those together. Then this is going to be 240, negative 240. And I subtract that, it's going to be negative 239 is my remainder. And I add those together. Okay, so this is a very messy one, so then I know my quotient is going to be 5x to the power of 3, to the power of 4, because we have 0, x squared, x cubed, x to the 4. 5x to the power of 4 minus 16, x cubed, plus 32, x squared, minus 6x, 61x plus 120, and then we have a remainder of negative 239. So that's a very big messy number. That would have taken us a while to do long division, but we could use synthetic that helps us out. Now it says, find the value of the polynomial when x is replaced by negative 2. Okay, so let's try that out. So we're saying when x is replaced by negative 2. So that's going to give me 5, negative 2 to the power of 5 minus 6, negative 2 to the power of 4 plus 3, negative 2 to the power squared minus 2 times negative 2 plus 1. Okay? So I look at this. This is going to give me 5 multiplied by negative 32. And then we have minus 6 multiplied by 16. Then we have plus 3 multiplied by 4. Then we're going to have plus 4. And then plus 1, which will end up giving me a total of negative 239. So notice that's the same thing as my remainder when we plug it in. That's kind of interesting. So comment on your answers in A and B. So the remainder is the same as replacing the polynomial by -2. And that's essentially what is happening. Let's take a look at the next question. It says, if x plus 3 is the divisor in the following synthetic division, calculate the values of m and p. So we want to find m and p. So this is going to be -3. So we have -6. This here, we add these together, I'm going to get -4 multiplied by -3 is 12. So now, this is kind of interesting. Then we have m, 2n. Okay, so this n is equal to, we know n is equal to -6m. We also know that there. We also have this here, that m, -m plus 12 is equal to 2m. Okay? So if I solve for that, I'm going to get m is equal to, move this to that side, so it's just m, move this to this side, switch that to that one, so I'm going to have 12 is equal to 3m, so I get m is equal to 4, solve for m. I almost made a mistake doing a simple math thing like that. See? Even your teacher can make a dog mistake. Now we have that is equal to 4. Okay, so this is 4, this is 8. Okay, that makes sense. So that's going to be 8 and 4. Now, we have -3 times 8 is going to be 24. Okay, 24. Sorry, there we go. We have -3 multiplied by 8 is -24. So then we have 16 and 24. Then is equal to -6m. And m is equal to 4, which is 24, -24, which we found out before as well. And we have that as -24 by going the long way, so that's 2 ways of getting there. And then we add these together, so then we have 16 minus 24 is equal to p. So we add that. P is equal to 8, -8. So we found both of my values. Okay? Now let's take a look at class example number 4. So here we want to determine the value of a. All right? So we know the remainder and everything. So let's set this up. All right, so I have -2. We have 2, -4, I have a, and then here I'm going to have 3. And my remainder is 3. Okay? So if I look at that, this must be 0. Okay, because -2 times 0 is going to be 3, because we're adding, it's got to be 3. So that must be 0, so we have 0 there. So I bring this down, we're going to have 2. 2 times -2 is -4. We add that together, and we get -8, which is going to give me 16. So I look at this now, a must equal to 16, because this has to be 0, because this must be 0. If that's 3, that must be 0. So a must be equal to -16. And that's how we get that one. Okay? All right, so let's take a look at the next synthetic division. We want to take a look here. It says the polynomial of each. All right? Okay, so I'm going to start with example number 5 and solve this for you. All right, so it says divide this using synthetic division. So we have 3x plus 2. So remember, we're going to have to solve for x, make it equal to 0, right? We want to make 3x plus 2 equal to 0. We're finding the roots of this, which is x is equal to -2 over 3. So here we're going to go -2 over 3. And we have 6, -8. Here we're going to have -5 and 5. Okay? So let's try this out. Bring it down, we get 6. 2 over 3 times 6, which is going to give me -4. Okay? These together, this gives me -12. Okay? Times 2 divided by 3, so that's, if we divide that by 3, that's -4 times 2 is -8. -8. Then we add those together. This is going to give me 13. Oh, just wait. -8. Oh, that's +8, because negative times negative is positive. So add those together, it's going to give me 3. Now I multiply this by this to get that. I'll multiply these together. I'm going to get -2. Add those, I'm getting 3. So there's my remainder, okay? So it writes everything else. So I have 6x squared minus 12x plus 3, remainder 3. And we want it in this term there. So I'm going to have 6x to the 3 minus 8x squared minus 5x plus 5 is equal to, I will have 3x plus 2 multiplied by 6x squared minus 12x plus 3, and then I have to add 3 more again at the end. And that is how I find my solution. Once again, I started running out of room and had to cram it all in. But hopefully you get all that. If you have any problems or any questions, ask me tomorrow as we work on this together.